Okay, here we go. Factor. Lily, we're up to you. What's the M and what's the A, please? The two numbers from the left, please. Go ahead. Good. Okay, good. Taylor, I have 3 and -4. What do I do with the 3 and the -4?
X squared.
Yeah.
Plus 4x.
No. Minus 4x.
Minus 4x.
Yeah.
Plus 3 minus 1.
Yeah, plus 3x minus 1. 0. And note, although I'm being mean, I said don't use the quadratic formula, okay? Because it equals 0, technically you could, okay? But it's a lot faster to factor here, right? Georgie, what's common, please, between 12x squared and -4x? What's left inside the brackets? Okay, good. Sarah, on the right-hand side, what's common between 3x and -1? 1. Good. And what's left inside the brackets? Okay, now I don't know if you guys know this, but Sarah is the best factorer in this class by far. So I know this is right no matter what. How else can I tell this is factored properly? Brackets have got to be the same, okay? They have to be or else it doesn't work. David.
I got -3x plus 1.
And then you had -4x minus 1 then too? Then you had -3x plus 1 and -4x minus 1? That's technically still right. But
No, because you can't.
okay, so what David did, hold on a sec, guys. Guys, I gotta keep moving here because I want to, we might have time for review today, okay? The way David said that he did his, the way David said his is he did -3x plus 1 and then -4x minus 1. That will still fall out to be the same thing, and you'll still get the same roots, I think, at the end, right? So it doesn't, as long as you get the roots, that's fine. All right, so there is that. Let's get on to today's lesson. Oh, which I lost. Okay, so our quadratic trig equation will have sine 2 squared, sine squared x. I'll call it beta, I guess. Okay, where have you seen something like this before? Where have you seen that before? In your identities, right? We're going to solve using, not in the general case, but in a specific case. Good afternoon. Whoa. All right, who's like? Yes, no problem. Riley, as soon as it's convenient, try to after 2 examples to understand those chemistries. All right, so this is the idea. Is this looks like identities. It's not going to be because we're actually solving a specific case. The thing that identities did for us is that we found numbers that every single, right guys, it worked for every single angle possible. Okay, right? So it wasn't like we just said it only works with theta equals 40 or whatever. All right. So here we go. Things to remember. Number 1 is quadratics are solved by factoring. Or a quad formula if you have to. I'm not going to stop using quad formula, but I really hope you don't. Okay, the questions I will give you nice solutions, right? Number 2 is you're still using this. And thirdly, you may have to use these ones as well. But that'll be more at the end of the class. We'll deal with number 3. Right? And then for the rest of today, we're just going to factor. It is possible to get impossible solutions. Okay, so I should write this on here finally to say number 4. So sine theta is greater than 1 or sine theta is less than 1, no solution exists, and that's okay. Okay, it is okay to have no solution on these. And I'm teaching grade 10 next semester, and it makes me so happy because I will not hear the word error. I hate when somebody says like in the quadratic formula the answer is error. It's okay to have no solutions. It's not an error, all right? Okay, ready to do examples for us, period? I think so. Like it's the last note ever going to take. So you have me next year for advanced functions. George is always smiling. He's like, yes, I've done that. Okay. All right, example 1. Let's say solve. Okay, this is something you're going to see like this, something on the test tomorrow, or quiz tomorrow. Okay? I guarantee. Okay. So it says solve thetas between 0 and 720. 2 sine squared theta plus sine theta minus 1 equals 0. Right? What does that sort of look like? And the hint is we've already done an example like this today. What does that sort of look like a lot? It looks a lot like a quadratic, okay? So I'm even going to make it easier for you. I'm going to set x equals sine theta. If I set x equals sine theta, Amy, what is that going to change my equation to be?
2x squared plus x minus 1.
Equals 0, but yeah. Why might I want to have done that? Why? Like, this is an optional step. Okay? Yeah. Go ahead, Logan.
So it's a lot easier.
Yeah, well, now we can just easily factor this. Everyone in this class did like 100 of these last year, right? Hopefully. Yeah. All right. Can I get a brave volunteer to factor, please? Only volunteers. So last day, I'm not going to get one volunteer the entire year.
Multiply to -2 and add to 1.
Multiply -2 and add to 1. Logan, what are those two numbers, please?
2 negative 1.
And -1. Okay. All right, Kirsten, what do I do, please, with the 2 and the -1, please?
You put them into the x.
Okay, go ahead.
So it would be 2x squared
Yeah.
plus 2x
Yeah.
minus 1x minus 1.
Now, if you're in calculus, or you don't need to substitute, you can write this if you want to as 2 sine squared x plus 2 sine minus 1 if you don't need the substitution. Right, and you'll still factor the same way. All right, Madison A, because I skipped you last time. Can you please factor the left-hand side, please? What's common? What's left inside the brackets?
X plus 1.
Good. Madison T, can you factor the right-hand side, please?
Okay, so I just took out a -1. So
Good, and what's left?
bracket.
And again, the two Madisons are the two best factors in the class, so that's right. It's also correct because the brackets line up. Brooke, can you be brave and give me the next step, please?
So you put it into brackets, so one bracket is x plus 1 and the other is 2x minus 1.
Good. Okay. So Julia, what are my roots, please?
-1.
Yeah.
And positive 1 over 2.
Okay. So I'm done, right?
No.
No, I'm close to being done though. What would my next step be? This is the moment of brilliancy. I have what x is. What do I do to finish up? Stub it back in, right? We're going to say, but
X equals sign.
so we're going to have sine theta equals -1, or sine theta equals 1/2. Okay, Caitlin, using the power of your calculator, can you solve the left-hand side for me, please? -90 is unfortunately, it's correct, but how does this? I made a fun saying don't say error. It's correct, but it's outside of my domain, right? So we don't want that. Okay. So how else can I get another angle for that one? Gabriella, how else can you get your second angle then? Still with on the left-hand side, we'll forget it with this right now. Since we did sine, how do you get your second angle then?
180.
Good. I'll do that here. This is where you have to be organized because there's a lot of minus -90, which should be 270. And you guys hopefully have a big page and do lots of different angles. Okay, good. Logan, what is the coterminal angle to the green one on the left? Like further down the page to the very left, -90. What's the next angle to -90?
Wait, what are you, what?
Like going down the page, what are we adding to -90 here to continue?
180?
Nope. Sorry, I meant to say, I'm sorry, that's incorrect. Well, what do we add to these always?
Oh, 360?
Add the 360, which is the period, right? The period for this one, because it's just the period, says 360. And you should get, what are we at? 270? Whoa, that's weird. 270, 270. Weird. Yeah.
Where did you get the... Oh, never mind.
Good. Please ask, this is new and weird, okay? It's the last new weird things.
First part, like you switched around to get theta equals sine, like inverse sine. I got all that. But
Yeah.
then where'd you get the?
So -90 is just what the calculator spit out, I think, was this one.
Oh,
Inverse sign.
So inverse sine of that should have got it was -90. So the calculator split there, then I did 180 minus to get the other one. Okay, great. So I have this one here, 270. I'm going up to 720. How do I get the next angle to the blue one? That's 360. Which is your period, and you get, what is that, 630? And I think that's it. The reason I'm done is because these 270s are the same. So if I add, right, 270 again, if I add 360 to the left, I'm going to 270. Unfortunately, Amanda, I'm still not done this question, which is why people love quadratics so much. Because there's going to be double the solutions. Amanda, what have I not solved yet? The whole right side. So how do you solve the right side? First step is what? Good. So it's going to be, I'll do some black maybe. Theta is sine inverse 1/2. I think that should be 30 for my special triangle. Can someone confirm that? Okay, Jesse, can I get another angle on the right-hand side, please?
You subtract 180.
Good. Yeah. Or I'll do this one. I don't know what blue. Theta is 180 minus 30, so theta is 150. then we're just gonna add 360 again. Sorry, I'm moving, sorry. What is that, 510? Okay, there's gonna be tons and tons of answers. Okay, the graph of that graph is wonderful, and you'll deal with it in calculus to graph it, but not today, yes.
How'd you get the 360?
Because that's gonna be your period, right? It's only 360. Because it's 360 divided by the number in front of theta, right? Like before we did sine of 2 theta, it would be like 360 divided by 2 to get the period, or like whatever. But in this case, because it's just theta, you don't, it's just 360. And I think for the quadratics, it's always going to be 360. I'm not going to do, because we're running out of time, I'm not going to do like sine of 5, sine of 6. How you doing? Look at what you This is the last day of school, of course it's difficult.
Yeah, I'm gonna slow down. I don't want to yell at Taylor.
Taylor, I'm not going to yell at you on the last day.
So we're done then? We don't have to do any concluding statement?
No. Example 2. Okay, I'm going to pause in the video. Go a sec. I'm going to pause in the video. I want you guys to try this right now. Okay, you can do it. 17 minutes. No,